Hi, this is Patrick Hill from Triple Point Environmental. Today I'm here to talk about a little bit about lagoon aeration, how we approach designing a lagoon aeration system and the types of information that we need to know in order to properly design a system, along with some of the pitfalls of the common mistakes that people make when they're looking at designing lagoon aeration systems that we try to avoid here at Triple Point. So I'll start with the definition of aeration. Because I think it's very important to know that as you're starting out and designing an aerated lagoon system. Aeration, according to the EPA, is not only the efficient addition of oxygen for the metabolizing microorganisms, but also mixing. And mixing is so critical because you need to get that bug, you need to get that oxygen, and you need to get that food mixed together. And if you can accomplish those three things, the better treatment you can get. And the driver to that in most instances is actually mixing. So we use two calculations here when we're determining the level of treatment through a lagoon. First of all, we need to calculate the field transfer efficiency, right? So of the amount of oxygen that we need to put in the water in order to break down the waste, which is typically 1.5 pounds of oxygen per pound of BOD, and 2 milligrams per liter of additional residual dissolved oxygen to get what we call our AOR, or actual oxygen required. How does that translate from our lab clean water testing numbers into the field? And that's what the field transfer equation accomplishes for us. And the second equation that we use is the biological treatment calculation. And the biological treatment calculation, just to sum it up, is a compendium of the field transfer efficiency equation, mixing rate, and site conditions. Those three things determine how much BOD you can treat within any given lagoon system. So when people come to us and they say, what do we need to tell you about our lagoon in order to design a system? Well, the first thing we're going to be looking for is lagoon volume, right? And that includes lagoon dimensions, lagoon depth, and sidewall slope pitch, because that tells us how much water is in this lagoon, and ultimately, in addition with the flow rate, tells us how long the water is sitting in the lagoon itself, which is really important. That's what we call hydraulic retention time. The other thing that the lagoon volume tells us and the dimensions tell us is how deep the lagoon is. Lagoon depth is a very, very key parameter in that field transfer efficiency equation. Generally speaking, the deeper the lagoon, the more oxygen transfer we can accomplish. And that is very simply because the bubble has more time to rise through the water column and transfer oxygen to water the deeper the lagoon is. So we really, really need that. Loading rate is also really important. How much BOD are you putting in there? What's the milligrams per liter? Or what is the pounds per day? How much TSS and how much ammonia, nitrogen, or whatever contaminants else you have in there? That is a key parameter because that allows us to be able to design enough oxygen into the system to be able to treat that organic loading. Next thing we like to know is whether the lagoons operate in series or in parallel. Really important. If they operate in series, they tend to operate a little bit more efficiently from a biological treatment process point of view. If they operate in parallel, they tend to be a little bit less efficient, but that is going to tell us, how we design the aeration system in either lagoon in order to accomplish your effluent objectives. Mixing is important, and generally we'll run several different scenarios. We'll run what we call a partial mix scenario, which gets a lower level of treatment. We'll run a vigorous mix scenario, which gets a higher level of treatment, and a complete mix scenario, which will run even a higher level of treatment. And so you see there that the mixing rate actually determines the level of treatment within a lagoon and not necessarily how much oxygen you put in the lagoon. And that's because, like I said, the definition of aeration, we got to get the food, we got to get the bug, and we got to get the oxygen together. And the better job we do those three things, the more treatment we can get in the smaller footprint, faster timeline. So we look at that. What's the mixing rate currently, or what do we want the mixing rate to be, and ultimately to accomplish our effluent requirements, right? Which would be one of the most important factors in this whole thing. Where are you now in terms of BOD coming in? Where do you want to be in terms of BOD coming out? We take those into consideration when we're looking to design your system so that we can meet those effluent requirements using your data. And then finally, what type of wastewater are you dealing with? Are you dealing with industrial wastewater, municipal wastewater? If it's industrial, there are thousands of different types of industrial wastewater, and that ultimately informs our field transfer efficiency equation, because if it's pulp and paper wastewater versus municipal wastewater, we need to put more oxygen, or we need to put more air in the water in order to transfer oxygen to water than we do in municipal, because that bubble is not as effective in dirtier water than it is in cleaner water on the municipal side. And then the thing over and above that is just temperature. And a lot of times we can just assume the temperature based on the zone it is in the United States. So based on where the site is, we know if it's colder, and that really helps us inform both our aeration design, but also our biological treatment. We can model what's going to come out of your lagoon based on the temperature, the worst case temperature, both high and low, that we're going to see. So finally, the common pitfalls that we see. Well, one thing we see a lot of is that people fail to account for sludge. And sludge throws two curveballs at you. Number one is sludge is, in some cases, undigested BOD. So you could have aeration out there pounding away at the water, and it could still see a DO of 0. And you scratch your head and you're like, Pat, why is there a DO of 0 out here if we're pounding away with our aeration? Well, we installed our system in 5 feet of sludge. Well, if you have 5 feet of sludge, that is undigested BOD. That requires oxygen too. That's taking in oxygen in addition to the sludge, in addition to the BOD that's already coming into the system. So that is really something that needs to be accounted for and measured, ideally before you even finish up your design, so that you have an understanding of where that sludge level is. The second thing that sludge can affect your Evolve treatment is sludge displaces volume. So if you have 5 feet of sludge in your lagoon, and your lagoon when it was built was 10 feet deep, it doesn't hold as much water anymore, because that sludge is taking up a lot of the space for that water. So your retention time through the lagoon is half as much as what it used to be. Now that obviously restricts treatment. So sludge levels is a really, really good thing to have a handle on if you're a lagoon owner, if you're looking to upgrade your lagoon aeration system, or if you're an engineer that has a client looking to upgrade their aeration system. You really got to know how much sludge is in that lagoon, because otherwise you're kind of flying blind. Influent BOD data. This is another thing that we run into. There's a lot of lagoon systems that don't keep influent BOD data because they're not required to by the state. And so nobody knows what's going into their lagoon. And you can definitely make assumptions based on population equivalent. But if you've got, an industry on your system and they're putting BOD into your system and you don't know what your influent BOD is, it could be much, much higher than you think it is. So it's really important to pull multiple samples. I mean, you can pull a grab sample and that's fine, but a grab sample can vary by time of day, whether you take it in the morning versus the afternoon versus the evening, and it can vary based on lots of different conditions, like a preceding rain event that might come in and dilute that influent sample. So it's really important to try and get as much BOD influent data as you can so you can make an accurate representation of how to design the aeration system, because ultimately, if you don't know how much BOD is coming in your system, you're never going to be able to design an aeration system accurately. As we say around here at Triple Point, good data leads to good decisions, and that's one of our core values, and we stand behind it. We bang that drum all the time, and that's because it's absolutely critical in a lot of factors, certainly when it comes to designing an aeration system. The third thing that can be a potential pitfall is unknown conditions, unknown things that are coming into your lagoon that you don't know about. And we see this a lot with industrial. I have literally seen water coming from an industrial facility going into a lagoon that is neon pink. And you're like, what is that? That is not good. And so having a handle on what your industrial providers are flushing down the pipe, or even what your local residents are flushing down the pipe. There's a meth lab that decides to dump all their chemicals down the drain. Now that's going to kill your lagoon. That kills the biology. right? And so you got to have a handle on that. And that also can constitute a BOD demand, that can constitute a COD demand, and it can be inhibitory to the ultimate biological process that you're trying to promote. So making sure that there are no unknown contents, making sure that you have a handle on what contents are going down the drain. And then the other thing is insufficient mixing. There are a lot of aeration system manufacturers out there, and they will sell you the most efficient aeration system in the world. They think their SOTE is 3% per foot of submergence. Well, that's just fine. That's fine. But if you're not creating mixing and getting the food, the oxygen, and the bug together, it's irrelevant. It's absolutely irrelevant. You could get a tanker truck full of oxygen, pump it right into the center of the lagoon, and you would theoretically have enough pounds of oxygen in order to provide the bacteria with the oxygen they need to break down the waste. But if it's not evenly distributed, if it's not mixed, and if you're not doing a good job getting the bug, the food, and the oxygen together, you're not going to get the job done. So those are the key potential pitfalls that we see. And that is exactly why we designed our Mars aeration system. It both has a fine bubble aeration component on it that provides the oxygen for the food, the bugs that they need, and it has a coarse bubble static tube on it, which helps to get the bug, the food, and the oxygen together by creating circulation and turbulence. And so if you're interested, we are perfectly happy to do a design for you. It's totally free. We have engineers in-house that do these aeration calculations falling out of bed in the morning. We are experts. We've been doing this for a really long time. If you would like, we can send you this form that will help you fill out all these boxes, send it in to us. Or we also have a form online on our website, the address right down here at the bottom of your screen here, that you can fill out and send in to us, and we'll provide you with an aeration design, detailed aeration calculations. We'll share with you all of our modeling data that we can in order to help you to design a lagoon aeration system effectively. So thanks for listening today. If you got any questions, feel free to comment on this post or email me, patrick.hill@tpenv.com. If you're interested in more videos like this, we do have our Lagoons Do It Better TV channel, which has lots of different videos on lagoon topics. Also, obviously, our Triple Point Environmental channel here, we post all of our webinars and our case studies on this channel. Really interesting stuff. We got lots of cool drone footage, so please check it out. We also have a blog on our website. So thanks for joining us today, and I hope I get to work with you soon.